My examples, let us see these two here. Now here we are going to see when we can use impulse and then also momentum. So what I'm seeing the relationship between momentum and then impulse. A bullet of mass 30 grams, so that our weight mass is 90 kilograms, is fired in a block of wood at the speed of this. If the bullet is brought rest in 0.2 seconds, find the average resistance exerted by the wood. Okay, so in our solution, so in simple terms, find the average resistance in the simple terms they're asking for the force. What do we know? In that orange, our impulse is equal to change in momentum. Our impulse is going to be Ft, force, the constant force, is equal to change in momentum, which we are going to say U minus V this time. This also change in momentum. Now, here, first of all, they are giving us our mass. So our M is going to be 30 grams, which is going to be 30 over 1,000 kilograms. So our mass is now 0.03 kilograms. Okay, so I have my time. I have T there as 0.02 seconds. So from here, what is remaining? At the speed of this, so this is our speed. So when it hits into the wood, it means that our final resistance is going to be 0. So that's why I'm talking with U minus V. So from there, substituting in there, see that I have F into now 0.02 equaling our mass, which is 0.032. Now our U from here at the velocity, so meaning that our U there is going to be 400 meters per second. So never start our velocity, the final velocity is 0, we start with U, then minus V. This is going to be now 400 and minus 0. So substituting here is that our F is going to be 600 newtons, and that will be our answer. So let's come to this. A stone of mass, okay, so it's summarized. A stone of mass 5 kilograms is dropped from a height of 10. So they are giving us our S, a height of 10 meters. Meaning if it's dropped, it means that its initial velocity is 0 meters per second. Above there is a number. Find the impulse find the impulse exerted by the ground on the stone if comes pressed without rebounding. So coming pressed means that we need our final velocity there. So the impact, that our impact is okay. Now from here it's that our distance is 10, then our initial is this because the body is being dropped. So we need now to know the velocity at which this particle is going to cover the 10 meters. So now it's been dropped in 10 meters distance here. So you need the V there. So from, of course, from RV squared equal to U squared, then plus 2AS. So from here, so it's going to be acting with the acceleration due to gravity. So this one now becomes our G. So from here, because it's coming this side, our A is going to be G. It's dropping, so it's gravity acting upon it. So this one, RV squared will be 0 squared, then plus 2 into 9.8, then times 10. So my G squared there, it will be 196, and that one I think our B becomes 14 meters per second. So we have this, meaning they're now unstressed. Find the impact. So they are looking for that impulse. So our impulse is given by change in momentum to be B minus U. So my I is going to be 5 into 14 minus 0. So my I here is going to be, that is I think 70. This will be, yeah, I think that is 70 Newton second. That will be our impulse. Now this one happens if the body is just falling and then it rests there. Because from here, now the distance is going to discover in this. That's how we're going to be with it. Now, when we come to part B, here we need to put a simple sketch. So first of all, this one is being dropped. It's going to come here. Now, it's going to hit the ground. Then it's going to cover some distance here, which is 0.1 meters there. So meaning now, this velocity here is hitting at here. Our B here, let us call it now, it's going to be 14. And it is hitting, then it's going back. Meters per second, let us call it V1. Now, you see when it's going this side, it's acting against this velocity. So this one is going to get -2. But maximum there, remember that at max height, initial velocity is 0, and then final V is 0. So now let us you know that from V squared equaling to U squared minus 2ds. So start the distance, you want to cover this distance here. So from there, you start this one is going to be 0 equaling to, let us call this our V2. So V squared 2 minus, because it's going against gravity, that's why we have a negative here. In this direction, our acceleration is -v. So then -2 into 9.8, then times 0.1. And take this side, V squared 2 will be 1.96. Yeah, 1.96. And so my V2 is going to be 1.4 meters per second. So now I have my velocity here, I have my velocity there. So meaning that now my impulse there will be m. Now it's like this one is bigger than this. So remember, this one is negative. There, this V, you see it was acting negative in the negative direction like that. So meaning I'm going to treat it as a negative also. It's not be now V1 minus V2. Because it was negative, coming, then going. That's why it's negative. It's changing direction. Simple terms, after the impact, it's changing the direction. So the velocity is changing direction. That's why I have it as a negative. After impact, this velocity was in this direction, but after the impact, it changed the direction. That's why I have it as negative V. Let me put here. Change in direction. Okay, that's why we have it like that. So from here, my I will be 5 into 14 minus 1.4. So implying that this will be 5 into 15.4. And so my I, the impact, is going to be 77 Newton seconds. And that's what we are going to be having the impulse. So that's how you handle those two cases there. I wish you well. Here I started with V1 because it was bigger, not want negative. So change the momentum can be, you remember this formula when we have what? When we have M1, or when we have MU equaling MV, you can get this as U minus V equaling 0. Or can have it as M when take them aside. So it's up to what you want. If you want it, you want to take this side, you get this. If you take this side, you get that. As simple as that. So equaling 0 or this equaling 0. It's up to you. Or that's why we are able to interchange them the way we want. So that's it, members. See you in the next lesson.